From door locks to smart TVs, IoT devices are part of the human DNA. A large number of security flaws exist due to inability of imposing strong authentication and authorization controls to granular levels. Bad design practice gives results to inherent vulnerabilities. Secure or Get Compromised is our next talk for the day by Dr. Aditya Sood, who is the Senior Director of Threat Research and Development at F5 Networks. The talk unveils how embedded web servers used in IoT devices are exploited by adversaries to trigger advanced cyber attacks. So let's hear it from Aditya.
Everyone. Today we are going to talk about secure or get compromised, unveiling the web security in IoT devices. First of all, I really want to say thanks to Hope Conference for giving me this opportunity to discuss my research. And let's get it started. Before moving forward, I really want to talk about some of the research that we have done in a specific context. But before doing that, I really want to lay some disclaimer. All the research that I have done in this field, it's not related to any of my previous or present employers. It's just purely for fun and motivational purposes, and to sharing the intelligence with the community. So brief background of mine. I hold a PhD from Michigan State University, working in the security field for more than 13 years. Speaker at industry-leading security conferences, author the Targeted Cyber Attacks book, and rest of the background I think you can check if you're interested by going to my portal, and the address is listed there. So let's get to the agenda. So today we're going to talk about the state of connected devices, current and a future state, embedded web servers, real world case studies, embedded web server exploits or malware case studies, discovered web HMIs, some of the SCADA devices that have been analyzed and discovered, unsecure and unauthenticated on the internet, and some of the questions and queries that you have later down the end of the presentation. Before moving forward, I think let's take a look into the world of connected devices, present scenario. I mean, some of the, I put up a screenshots and the small news outlet headings here talking about, why IoT is, important these days, what we are seeing, why home security is an issue, why IoT devices, available on the internet are not secured well enough, and some of the associated problems. But the interesting part here is that I think we are living in the world where IoT is becoming much more prevalent. And in order to make sure that IoT devices are secure, we really need to invest significant amount of efforts into it to ensure that this infrastructure stays secure. At least you'll get an idea why this topic is relevant these days and why, as a security research community, we need to invest efforts into it. So let's take a look into the current and a future state. So if you can see in this particular chart that I presented here, you can clearly see starting from 2015 to coming 2025, what we are actually gonna encounter. We are kind of going to talk about, close to $21.5 billion of market cap in IoT devices reaching by 2025. And how it started from 2015. So overall, it reflects that there has been an exponential growth in the usage of IoT devices because of the connectivity of various devices, which means the world is getting more dependent and the data movement is happening among a lot of devices. So this actually raises an eyebrow that we really need to think about investing research efforts into this direction as well to make sure data stays secure, devices are secure, and we will present a very better environment and infrastructure for the users to actually go after. Moving forward, I really don't want to talk about some of the basic things, but I really want to dig deeper into some of the real world case studies, what it means exactly in this context of the presentation. So we found a lot of interesting, security vulnerabilities, issues in some of the web servers that are being used by a number of IoT devices. So what we want to target here is that we're going to take a deep dive into those vulnerabilities. So we're getting a little bit more technical here because we have just got an idea why IoT is important, why we really need to invest security efforts into it, and how much the market's gonna be, like how it's exploding in the coming time. So let's just get it started and think about and take a deep dive into some of the technical aspects of it. So in this part of the presentation, we are going to talk about browser-based JavaScript protections, insecure password storage, weak cryptography, credential leakage, unauthenticated web resources, injection attacks, cross-interface attacks. Let's take a look into the first one. So in a couple of the IoT devices, when we're doing research, we found that most of the access-based mechanisms like access restrictions and access rights are configured by simply using JavaScript, which is a very bad design practice if you ask me, because JavaScript is on a client side. We want to have validation on the server side. And in a couple of devices, what we have seen that they have implemented very specific browser-based detection. So for example, let's say you're opening up a web interface of the IoT device in a browser. A JavaScript is rendered into it. It executes and checks for specific validity. And then it actually perform next set of functionality, which is totally fine. But here's the explicit check is actually done by JavaScript. So what if we bypass the JavaScript? What if we use another client like curl or wget? Let's take a look into it. So I'm talking about presenting on one example here. Take a look at this web interface, and then what we are saying here is a timeout login again, which means that the JavaScript is checking the validity for what extent the session is active, and if it is not is expired, that is going to give you this thing. But if you look at the workflow model that I have actually presented here, let me call it an execution flow. So we initiated this test, and what we want to do is we want to download the system information file, which is like sysinfo.gch. But JavaScript protection is there because what we are routing it through is we are opening the web interface in a browser. And when we saw that, it exactly highlights an error like test is failed, you can access that file, because what we are trying to do is we have the complete URL path to the resource, the system information file, and we want to actually download it via browser, which means JavaScript protection is triggered, and it does that in a completely unauthenticated way. So what next? Let's try to just subvert this integrity check here. And what we did in this case, rather than bypassing or rather than actually utilizing the browser, what we went ahead with, we basically used the curl tool, and then we just simply hit the resource. To no surprise, actually the request was accepted, because right now we are not actually harnessing the power of browser so that the JavaScript file actually gets rendered into it and perform some kind of verification checks. Right now we completely bypassed it. What it means, like when we are able to dump the sysinfo file here, and you can clearly see the content of the file here, that what we got it, and then we actually went ahead and we also used wget tool, and we are able to dump the security configuration file. And when we dump the security configuration file, you can clearly see we're able to get the conference password value, which is kind of pretty default or easy to crack. And then you got a lot of interesting information. So right now we simply bypass the JavaScript protection mechanism, which is being heavily used in the embedded web server design. In order to actually circumvent these controls, you need to find a different sort of bypasses, which means like bypassing the protection mechanisms. The interesting part in this case is that we need to avoid the usage of JavaScript as a verification, which means we shouldn't be doing any kind of client-side validation when we talk about web security in IoT devices. Let's move on to the next one. In this case, similarly, we extended the test, and what we want right now is we want to bypass the access protection that is being set up using JavaScript. And now we are fetching the security conf file. We got the password as I showed earlier. Now you can clearly see we are able to get the access to the complete IoT device, which is in this case is a video conferencing device performing different set of functionalities. So without actually exploiting any kind of performing any kind of remote code execution and things like that, we basically abuse the way this design is implemented by simply bypassing the client-side validation checks, and then we are able to kind of compromise the device. So let's take a look into the CAPTCHA implementation. Similarly, again, a problem with the JavaScript based control. In this case study, what we are actually focusing on, the implementation of CAPTCHA, and all in all together relying on the code or a kind of random number that is generated on the client side. Let's take a look at it, or simply a scenario where you are actually projecting that you are generating the CAPTCHA, but eventually this is a hard coded into the code. Let's take a look into it. So in this device, you can clearly see, when we try to log in into the router, it says like the CAPTCHA cannot be empty, right? Which means you have to specify. So there is some sort of like, client side validation is there, or maybe server side. That's totally fine. Now you can clearly see when we try to log in ahead, we pass the username, password, and then we pass the CAPTCHA code as well here. So in this particular case, you can clearly see we actually let the CAPTCHA to be sent with the request. Now let's take a look into the next one. What went ahead? So in this case, when we saw and dissect the HTTP traffic, you can clearly see an AJAX request is sent with HTTP parameter. No CAPTCHA value fetched dynamically from the web page during authentication, which kind of means that the CAPTCHA value is not randomly generated, or basically it is a kind of hard coded into it. And how we are able to figure it out, if you look at the encrypt type, it is set as to a plain, right? The plain is a hard coded value into it. Now, when we went ahead and then tried to actually, we want to see right now how the JavaScript code is working, basically the HTML code also. And now you can clearly see when it's sending the AJAX request, you are passing username and password, and encrypt type is plain. And there is nowhere you are actually passing the CAPTCHA code on the fly, which means that the CAPTCHA is kind of code is implemented in a very weird way. It has no relevance at the back end. Rather than if you just scroll down to the HTML code and extract the AJAX request, you are able to see what exactly it is all about. And now we understand it doesn't matter whether you have CAPTCHA implemented or not, it can be bypassed easily. So similarly, we have gone through two cases of bypassing JavaScript based protection, which is a very bad design. Now let's take a look into another use case, which let's call it as the way it is used and designed and implemented by some of the IoT devices. We categorize it into the weak cryptography and insecure tokens. It is much more related to the session management, how cookies are generated. And design flaw revolves around the fact that there are weak tokens can be brute force easily. And we saw that in a number and a variety of IoT devices. And in certain sense, we have seen that 4-digit or numeric numbers are used as a session identifiers or a value to be passed in cookies. Let's take a look into it. Now, in this code, what I'm trying to highlight here, if you look at this code here, this is the tool that I wrote. And then we are actually using this tool to actually automating the task. And then we drafted this tool, and it can send automated requests. But what it is going to do, it is going to use the already pre-populated 4-digit session identifiers. And you can automate the task, and you can keep on hitting the web interface of the IoT device, which of course has to be vulnerable to this design flaw. And then what you can do is you're able to bypass completely. Basically, you're able to find the right session identifier, and then you're going to get the access to the system. Let's take a look. In this case, I'm highlighting this is the web interface. And if you look at the HTTP traffic, the cookie is simply passed as a challenge ID. And the value is 7374. Actually, this gave me the idea here that we can automate it. It's a weak cryptography implementation. It's not random. And then if you look at the space which the 4-digit and then amount of identifiers it can generate, basically the numbers, we can successfully pre-populate it and then let it run through one automated process. So what I did, as shown, if you see, as shown in here in this part, so we automate the task. We extracted this intelligence from here because the cookie value is passed is like 4-digit. We automate task. And you can clearly see here when I trigger the code, we are able to actually fetch the right identifier, which in this case is like 7374. We bypass, we actually able to authenticate via an automated script, and you are able to see that we are able to dump the whole configuration file. Using the credentials out of this configuration file, we are able to access the system on the fly. So in this case, the very insecure way of handling sessions and generating unsecure and non-random numbers which are not complex in nature with the lower set of entropy is a very bad design that we have seen in a lot of IoT devices. So let's take a look into the next one, which is like cookies the credential carrier. We have seen that in a number of IoT devices, people assume that the way it is being designed, sometimes people think like bypassing by simply passing the values in the cookies is a secure mechanism, which in fact it is not true. And that's what we are going to discuss in this use case. So generally, where we have seen a lot of devices that are available on the internet with different functionalities and variations, some of the IoT devices follow weak session management. And that's what we are going to cover in this case study. Now take a look into this one. So when we have seen that you authenticate any kind of to the web interface of a specific IoT device, which in this case, it has to be vulnerable. When you send the HTTP post request to a specific file, you can clearly see a cookie is passed. And then the cookies actually contains user type null, session ID, user password 111, and then 111. Sorry. So in this case, you can clearly sense it out like, somehow this by default, this password and that parameter is being passed through the cookie. And this is being used on a multiple places, which means that somehow the embedded web server and the application, which is in this case a web interface, to access the device is like following a very design, which is called as a very insecure design practices, and it is allowing the cookie and the password is passed in the cookie. So that is not at all a good scenario, and which means that by simply looking into the HTTP traffic, and then if this traffic is sent in an encrypted fashion over non-HTTPS channel, which is like no TLS is used, so you can actually extract these credentials and you can get an access to the system. Now, we are just moving on to the next case study here. And this is much more related to, bypassing the access restriction, access rights, and fetching some kind of critical files on the system. Earlier, we have seen log files and all that. In this case, this is much more related to authentication bypass. So in a number of scenarios, what we have seen that, the way, because it's an embedded web server, anybody is like hitting this web server, accessing the web interface, log files will be generated, which is definitely required for like, understanding who is accessing the system, what it is being accessed and all those sort of things. So as for incident response, as well as for reconnaissance, this is interesting and important to actually get an access to log files. So there's one part and parcel of the information gathering exercise as well. But on the contrary, the embedded web server needs to make sure that either the developers who are developing the code, they need to make sure when they deploy the application core or the interface, they need to make sure the permissions of the various resources residing on the web servers should be securely configured. Now let's take a look at it. Similarly, what we have seen that in a number of cases it is possible to fetch log files directly from the embedded web server. Let's take a look into this one. So in this case, when we're doing reconnaissance earlier, information gathering, we found that there are some flaws in the implementation or the access rights, which can be bypassed very easily. In this case, you can fetch log files directly on the fly. And here I was like showing you the example. It's a vulnerable device. We are hitting the URL resource directly there, and then we are able to kind of dump the file. Because the server thinks that this is a kind of internal txt file or log file, which is not actually required by the web interface, and they never implement any kind of explicit check on who's accessing this file. So without authentication, you can dump the log files and extract a lot of information out of it as well. And that's what I did in this case. And you can clearly see a lot of interesting information about the access of a web interface of a specific IoT device. All right. So let's move on to the next one. What we have seen in web interface design, that storage or persistence cross-site scripting one is very, very prevalent. And then the major cause for this is the user supplies arbitrary values are not validated and verified, are not sanitized on the server side, and ensuring that any code, any HTML code that can be executed into the web browser should be prevented. Well, that's not at all the case, and we have seen that advanced cross-site scripting vulnerabilities can even lead to remote code execution as well with the specific payloads. Let's take a look into this one. In this example, I'm talking about one of the Netcom wireless router and a heavily used one. The problem in this case is that it is possible to actually inject the XSS payloads and it becomes persistent in nature. So what it means, like once you inject the code, it's gonna stay in the web session, or it's basically gonna say the account of the user where it is actually injected. Anytime you open up the web console here or the web interface, what it means, the code's gonna get executed every time. So imagine if you are able to inject HTML code or JavaScript that is able to fetch the malicious file from remote location on the internet. Any user of the system open that web page and every time the malware file will be fetched. So this is the kind of high risk scenarios, basically a part of the application security. But we have seen these kind of issues happening in some of the web applications. I would say web interface being designed and configured for the various IoT devices. Now let's take a look into the next attack, which I used to call cross interface attacks, and I will explain why I term it as. It is like advanced injections, but the way we actually trigger this attack it's pretty different. So it is all about injecting payloads, but what kind of interface we are choosing. And which means, like, when we talk about web interface, this is the HTTP protocol, you open it in a web browser and you start interacting with the IoT device. In this case, what we have seen that in a number of IoT devices actually provides different remote management interfaces as well. It could be HTTP, it could be SSH, it could be FTP, and it could be Telnet as well. So there is a one design pattern that what I have analyzed during this research is, whenever you provide any kind of arbitrary values, let's say, for example, you want to use the Telnet remote login interface, right? In this case, you provide username and a password, and you try to log in via the Telnet interface. And then, all that, user supplied values gets logged into the web interface, making sure want to make sure that who's accessing the Telnet interface, what they're exactly doing with the Telnet interface, and they actually put all that logs back into the web interface. In that case, what happens, that the whole component that is being designed to handle that logs, it does not validate what kind of arbitrary values are being supplied by the Telnet interface. And let's take a look into this one. Now in this case, I'm actually showing you one of the Telnet interface here, and then it asks for username. This is our attack point, right? So we will inject arbitrary payloads here. Now, in this slide, if you see what I didn't know the username or a password for this particular assessment. So in this case, you can clearly see that we supplied arbitrary values here, username and password, right? And similarly here. So basically, we are actually using these as the entry points to inject arbitrary payloads. And we did that. It's totally fine. Let's move on to the next one. And because we're testing this in a holistic way, so when we log in back into the web interface here, and we move on to the logs component, and you can clearly see here a lot of injections are getting rendered, which means that it is successful to actually inject a kind of cross-site scripting payload, cross-site request forgery payload, which gets rendered into the authenticated session and can trigger commands. So you can clearly see these injections lined up here. Now, in this slide, what we did, we injected the iframe with a link to the malware.com. So you can clearly see somebody logging back into the web console or interface. You can clearly see that that code gets rendered and the payload is executed. Every time you do that, you go into that particular vulnerable component, the code still gets executed because it's persistent. And in this case, you can clearly see we use the one remote management interface to actually attack the web interface and then actually executing the code. So what I actually mean by cross-interface attacks in this case. Now, so until this point, we have gone through 6 or 7 different use cases in the real world, where we talk about bypassing JavaScript protections, downloading files in an authenticated fashion, cross-site scripting injections, stored and persistent. We talk about cross-interface attacks. We went to the insecure CAPTCHA implementations. We also talk about insecure cookies and carrying credentials and things like that. But right now, I think it is much more important to understand how these attacks or vulnerabilities or configuration issues are actually weaponized by the individuals. When I say individuals, I will be more explicit in saying the adversaries. So in these few cases, I want to highlight that how exactly they are building automated attack scenarios and to actually target the broad-based IoT devices on the internet, and to ensuring that they conduct a distributed attacks and compromise a significant number of IoT devices on the internet. So in this sections, we're going to take quite a look into the 2 of the exploits cases. The first one is the Linksys router exploit variant and the HUAWEI home gateway. And the idea what we want to highlight is how these exploits are hard-coded and embedded into the binaries, and these binaries are fetched and installed on the IoT devices and they are executed. So looking into this one, now what we did, we find a vulnerable server, we are able to download the x86 payload here. So when I run a file command, you can clearly see it is an ELF 32-bit LSB executable. Totally fine. So, and we were going, and then what I did, I just did a very basic check. We just want to run the strings here on x86 and try to grab a specific CGI file, which is a vulnerable component. And we found that there's a post request, which is like a post HTTP request indicator is extracted out of it. So we detected an exploit signature. After that, we went ahead and then we actually kind of, perform additional analysis on the binary in a static way. And then we try to extract the whole HTTP post request, which is hard coded in this case. So you can clearly see this is the whole request we are extracted out of this x86 binary. In that case, you can clearly see authorization header is used, which means like basic authentication is used. And this is a base 64 payload. So when we decoded that, you can see that what was the username and password being used, and then the whole exploit that is being used in this binary, which means that they compromise the one IoT device and then they let it run to scan multiple IoT devices on the internet in search of a vulnerable device and getting it compromised to make it a part of the botnet. Similarly, in this variant, we did that. Similarly, the same variant, same thingy, and you can clearly see 2 different variants for the remote command execution payloads. And when you decoded the payloads here, you can clearly see how they exactly doing the remote command execution, changing to the temp directory, maybe installing the some kind of package, then cleaning it up, then from there fetching using the already available wget binary to fetch this MPSL file, changing the file permission mode and executing it, and then cleaning the directory. They don't want to have any kind of traces remain on the IoT device, so they just let it run and then they just keep on doing it for a longer period of time. So that's how they weaponize and automate these kind of exploits targeting various IoT devices. In the next one, in this case, I want to talk about HUAWEI home gateway. Similar case study. What I want to highlight is the kind of exploit. In this case, it's an XML based. The system that HUAWEI is designed, different IoT devices, they are accepting the XML based payloads, and then they actually process it in the same way. Similarly, we extracted this payload from the embedded binary, and then you can see here I have a very simple demo. Let's see. I embedded it and see it works. So I will a little bit forward it up to get to the real context. So what we are doing, we are trying to fetch a binary from the remote location. Here we fetched it. So now we are extracting the embedded HTTP GET and POST requests carrying the exploit payloads. So for this particular POC, I mean, I just used a very simple package file, but you have to perform number of different steps as well in order to reverse engineer it and sort of things like that. Yeah, so that's how these exploit files are actually embedded in the various files that are specific to different architectures for various IoT devices. It can be x86, MPSL, and sort of others. Now, another topic that I want to touch base is in 2019, there was this issue came up with HP IO systems ransomware, and we've been following this thing for like a period of 1.5 years. We are still seeing these kind of number of devices that are being still infected with this ransomware, and this is again a very important or you can say issue which needs significant attention, because now ransomware are also targeting IoT devices. If you look at this, when I actually found this vulnerable system which is compromised, and then I able to open it in the browser, you can clearly see a security notice is triggered here, and you can see that the message, the ransom message that has been displayed, and where they actually want the money, why the Bitcoin. And I have this small demo lined up and one of the vulnerable system to actually just show that how these problems are actually real in nature. So let's kind of take a look at it. So most of the HP IO systems have a basic device.xml file, and which we're able to fetch, and you can clearly see a lot of the information that is available into it, what version and things like that. So I missed the command here, but let's start it again. So what do we be able to fetch that, how the web interface kind of look like. So, and the important information related to basic device.xml file. So we are able to fetch the XML file, and here we are opening it up, and yeah, that's it is working. So it is accessible, this system, and you can see which model, which variant, and everything that is available. Now we are actually gonna fetch the web interface here. Of course, as a self-signed certificate, we need to accept it. And this is our kind of vulnerable system. And now you can clearly see the system is actually being compromised with a ransomware, and you can see the messages being displayed. Yeah. So the idea of this particular presentation to actually show that, the kind of threats that we are talking about is actually pretty real in nature. And you'll find a lot of systems on the internet that are still compromised with this kind of threat. A ransomware is not simply, targeting end users, but they are actually targeting now IoT devices as well. Yeah. So now we touched on two topics. We talk about 6 or 7 real world case studies, vulnerabilities that are, and design flaws that exist in the web interfaces. Then we also talk about how they actually weaponize those kind of issues, the security issues related to insecure configuration, inherent vulnerabilities, how they actually automate it, and how they embed those exploits and then let the binary run in a one IoT device, and then how they clean up the entire temporary directories to remove the traces. But another important aspect which I want to talk about in this SCADA space is as well to somewhat related to IoT if you take up the broad definition, but there are a lot of problems associated with the web HMIs as well. So HMI here holds the like human to machine interface, but it has a web component to it as well. But basically, via web interface, you can perform certain kind of operations that can directly guide the backend systems to function accordingly. So let's take a look at it. Here I'm basically gonna talk about interesting discoveries that we have and the insecurities that exist in the various SCADA infrastructure. Now this one is a one simple example of irrigation controller. This is a blue spray one. I mean, you can find a lot of these irrigation controllers. And then, depending on the functionality that is available, you can conduct some kind of, reconnaissance, information gathering. You can even utilize it to perform some kind of unwarranted operations using these devices. The idea in this case is try to highlight that, these kind of, devices are available on the internet, and if you have the right set of information, right knowledge, and what kind of indicators you need to check, you'll get an idea of it. So this is kind of pretty amazing. Here you can clearly see the whole the home here and the house, and where there's what kind of things they have set up, what kind of irrigation controllers, where they are exactly. Kind of fun here. But let's just move on to the next one. These are smart IP controllers. In this case, you can still switch on and off a lot of different outlets here, which means like here is output 2, output 3. You can, there's an input status which says these are inactive states, all the inputs, but you can actually switch on and off the input as well, because you can actually use this handle to actually perform that. And this is all happening via web, which means that you actually perform this operation via the web HMI, and the backend system and the backend design is like set up in such a way that it actually translates back to a command, and the command will be executed by the whole backend infrastructure and applications. Now let's take a look into the another one. This one is related to industrial control automation HMIs. Here, in order to actually get an access to it, you need to pass the 4-digit, and you can clearly see it might not be that complex, because if you look at this, like not cryptography secure, it's just like guessing, and you can how many combinations we're gonna have for 4 digits here. So yeah, you can do it, and you can actually able to bypass it, find the right one, or extract a lot of information from other components that are exposed. Similarly, in this case, login page is a 6-digit, but somehow we are able to find it out, and we report it to the appropriate guys. So you can clearly sense it out here, with this web HMI unauthenticated and this, and then probably you can actually already have an access to the system. You can conduct a lot of different operations, and this is what we really need to prevent. Actually, here we need to work with the vendors to make sure that even if you're utilizing these kind of technologies, in this case is web HMIs, we just want to ensure that you secure these devices, and making sure that much more robust security controls are being implemented. Anyhow, similarly with the next one, it's a recycle pump control, similar thing, web HMI, but it is available on the internet in an insecure way. Now, so looking at some of the examples that we have discussed in the context of web HMIs, it means like, we really need to invest a lot of efforts and time to actually make the SCADA infrastructure more secure. Since this presentation is entirely focused on the web component of it, we need to make sure that, the web interfaces, any web component being used, these are designed in a very effective way ensuring that the design cannot be compromised or abused, including any exploitation of a vulnerability and configuration flaws. But that being said, I still remember the very last time I attended Hope. I was like walking through that hotel in New York, and I was looking at some of the very interesting, visuals. And I took some pictures out of it to be used in my presentation, and I'm using again at the Hope conference, which is quite amazing. And I found this thing very impressive, and it's a great work done by the artist, contributors at Hope. And the message is very, very simple. They said, like, security isn't new, right? It is nothing groundbreaking, but it's up to you, right? We have the benchmarks defined. We are actually advancing on the security front with the new technologies. We're building new benchmarks, new baselines. But are we implementing it right? Are we following the standards right? I think that is the most important part. And I think that's where you can see it's a security and it isn't new. It's all up to you. So that's how we really need to start thinking in this space of IoT as well, ensuring best in the breed security experience that we can actually provide from in the context of IoT devices. So that being said, I'm kind of done with my presentation here. I hope this is of somewhat interest, and since although you are actually attending it online, hope I'm able to share some interesting details, interesting findings or intelligence with the security research community and the Hope team. I would say thanks again, and I really respect the kind of efforts and the work done by the Hope conference in still arranging the conference in these difficult times. I appreciate all their efforts, and if you have any questions and queries, I'm here. Thank you very much.
Thank you, Aditya, for creating more awareness on imposing strong authentication and authorization controls for our IoT devices. So now it's time for question and answers. Let me begin with the first question we've received. Are there any open source secure IoT framework to start with a focus on security?
Yeah. So I think there are a few available, but I think even IoT, if you look at this, is a kind of broad space, right? With the different variations, the way different devices are working. Even if you look at from the networking architecture, so it becomes very focus-centric approach when you try to build any IoT framework. We do have few which are being used by different organizations. For example, GE use Predix. There is a Zeta, and then there is a ThinkSpeak. A few of them are there already out there. For the IoT Eclipse, there is you can use that as well. But irrespective of that, I think what the question we need to focus here is that is the basics of security here, right? Even the embedded web servers, applications, interfaces, it is much more important to understand what is like a hardened baselines we need to use. So I always believe that basics are the hardest part to conquer. And that's where we, as a result of that, we think that basics are just like, okay, it's just normal, it's easy. But if you look at all sort of vulnerability, is the basics that are not being implemented efficiently. So you can have different frameworks, but the way those frameworks are applied, use these kind of security concepts also matters. I think it's a shared responsibility model to some extent. If you see recently that this IoT bill has been pushed in, has been passed to just enforce to actually implement a check where the username and password need to be changed for the every first time you actually deploy that device anywhere on the internet. So I think these are the small things, but eventually what we really need to understand here is that secure frameworks do help, but it becomes very product centric, right? I mean, you cannot have a one secure framework to applicable to all. So from that, I think hardened guidelines, basics, that what we really need to do when we perform solid design reviews when we're building these products.
All right, we have another question. You describe a CAPTCHA system. Do you think CAPTCHA should be abandoned entirely, or it is still worthwhile to have it on IoT devices?
I think again, that's a good question. I think it again, what I feel during the part of this research and few other with the generic web applications and all that, it all depends on the way CAPTCHA is structured and implemented, right? Any design framework. So we believe in whenever we build any design system, so we never build that design based on the fact that client is secure, right? The assurance, the baseline is like anything you implement on the client side is always insecure. So that's where you need to set the foundation and start building your system. Now with the CAPTCHA and all that, I think it all depends on complexity, and then how much it is going to harden or increase the complexity of the system to actually subvert or the attacks that are happening against the systems. Client side is always a no-no. CAPTCHA, it has to be really, really, designed in a perspective that, it's everything has to be on the server side, everything you generate, and it has to be, implemented in line with the defense in depth. Like you cannot say that you have implemented CAPTCHA, but all the other web security benchmarks are gone. I'm okay with CAPTCHA to some extent, but there's a much more need to be done from the basics of the security. I'm still sticking to my point. And I feel that, a lot more needs to be done on that side. Whenever we're building web consoles, web interfaces for the embedded web servers and sort of things like that. CAPTCHA is a good security, but nothing is 100% or bulletproof if you implement it in a very insecure manner.
All right, there's another question, Aditya.
Yep.
Would would you talk a little bit about upgrading IoT devices? What happens when manufacturers disappear away or they stop providing updates of softwares or firmware?
Yeah. So I think it is a very neat question, and this is very realistic in today's world as well. I think it's always I believe that there is a cost associated with upgrading as well, right? Because these are the legacy devices to greater extent, and once it is deployed, people believe that it's a sticky business, it's gonna stay there. We don't care, right? What is happening and all that, and then it also depends on the vendors as well, how fast they are releasing the patches and fixes, and and how effectively they are working in line with the customers or in conjunction with the customers to making sure that they update their devices. One of the interesting artifact what we have seen in the real world is that it also depends how complex the deployment is, right? And how much cost it is associated with that. So I think it is just not, again, I'm sticking to the point, it's like a shared responsibility model, how effectively vendors need to work with the customers, and also customers need to show a great, support as well to making sure all these devices are, fixed and updated. It takes time. This is not an overnight job because there's several dependencies that we really need to take into consideration. So it's need a well-formulated plan to actually go step by step to fix these issues, and then making sure when these issues are fixed, it does not create any kind of problems in the network or environment. But it's not an easy task. It's require well formulated plans.
All right. There's another question. Have you seen that some IoT devices implicitly trust other devices from the same manufacturer? Would that create a bigger attack surface?
Yeah, absolutely. I think in certain cases where we have seen them, I think it is so we actually dissect when we look at from design perspectives, like in a horizontal escalation scenarios and the vertical escalation scenarios. So it is basically if we are staying in the same horizontal way, different devices belong to different manufacturers. For example, let's say there's a manufacturer who has built this IoT devices and it has like a backend support for some sort of cloud service as well, right? And cloud service, how they are performing authentication checks on with the cloud service, that matters a lot. Sometimes we believe that whenever there's a connectivity happen, there is again, if under the hood of authentication and authorization control is very weak, because they assume that I'm sending this identifier to the cloud and fetching that data. That is kind of pretty understood. I mean, they use some authentication, but it's kind of very weak. If we look into the distributed way, like a device-to-device communication, I mean, we have seen not enough traces like that, because every device that goes, it follows a standard design and a individual model of security. And considering that, I think it could be a problem which needs to be well researched on that part. And that's where what we have, kind of seen in this scenario. But eventually, at the end of the day, it is much more related to the design of the systems, right? And usability is a one part of it, but eventually, at the end of the day, how it is being exploited. And we have definitely seen the pattern that has been followed a lot. I discussed in the talk as well, the weaponization part. You install that binary, and the binary is like using one IoT device as a launchpad, right? And then it definitely picks up some traces based on a pre-populated knowledge that is gained from the device. And when it runs distributed, it can be targeted, it can be broad-based, right? But when it is run, it is using the IoT device to perform different set of communication to other IoT devices, right? So even from the detection and prevention point, that we build IoT security solution, it needs to be checked why IoT device is communicating with IoT device in just a very random way or more frequently. And, so again, this becomes a part of analytics, how you formulate the patterns there. But definitely, IoT's devices are being used as launchpads to attack other IoT devices on the fly.
All right, Aditya, thank you so much for an interesting presentation. We are out of time, and we hope you would come back again and create more awareness regarding IoT or other devices that we use in the future. Thank you so much. For our audience, thank you so much for being part of Hope 2020. We will be back with another talk in the next 10 minutes. Until then, stay safe. Thank you.
All right. Thanks, everyone. Take care.